In this video, we're going to be talking about lines in the coordinate plane. So kind of a brief review of some algebra concepts. First, let's talk about what is the slope of a line. How many ways can we define the slope of a line? Well, we can actually define it a number of different ways. We can use words, we can use expressions, it's involved in equations, we can use symbols, all kinds of things. But here's some basics right here for slope. We usually use the letter m to represent slope in an equation. That's broken up into really a ratio comparing change in y coordinates to the change in x coordinates. And what does that mean? Well, the change in y is just the length between our two y coordinates between those 2 points, and we can find that length by subtracting them. We can do the same thing by finding the horizontal distance or change between the x coordinates, and we can just subtract those. So here's the slope expression, commonly used to find the slope between 2 points. We can also rewrite that just using function notation instead. So the exact same thing, just using different symbols. And then eventually, as you work your way through pre-cal and get to calculus, you're going to be working towards defining slope as a limit of the difference quotient. And so we're working towards that, but you typically don't get there until you're actually in a calculus class. So in pre-cal, we're definitely going to be focused on these two expressions right here, and mostly as we learn function notation, we'll just keep it like that. All right, how do we find the slope of a line, especially between 2 points? Well, we use this equation. We're going to subtract our y coordinates and compare that to the difference in our x coordinates. So given 2 points, you can label it x1 and y1 and x2 and y2 if that helps. We're going to subtract the y coordinates here, so 1 minus 0, and subtract the x coordinates below that, so 3 minus negative 2. Simplify that, and we get 1 over 5, which gives us a positive slope. If we have a positive slope, we know we're going to have a line that is increasing or going up from left to right. Now, some people like to do this a different way. They like to do it kind of backwards of what I did, but do not do it upside down of what I did. If you put your x values on top and the y values on the bottom, you're going to be totally wrong. So keep those y values on top and the x values on the bottom, and then you can subtract them really in any order you want as long as you keep your pairs together. So if I choose to start with 1 minus 0 on top, well then I got to start with 3 minus negative 2 on the bottom. However, we could do 0 minus 1 on top, as long as on the bottom we do negative 2 minus 3. We'll get the exact same slope. All right, so feel free to work through those other examples and then check your answers right here. Go ahead and pause the video if you need to. Two special cases that tend to pop up are where we get a 0 on top of our slope ratio, or if we get a 0 on the bottom of our slope ratio. If we get a 0 on top, we know that in math, if we do 0 divided by anything, that will equal 0. So if our slope is 0, we must have a flat line that did not move up or down, so it stayed flat, or horizontal is another way to describe that. If we get a 0 on the bottom, well, in math, we're not allowed to divide by 0. We call that an undefined slope if we see a 0 on the bottom of the ratio. And we know that an undefined slope goes with a vertical line because it doesn't have any run. It's just going straight up and down. And because of that, we say it doesn't have a slope at all. And we call that undefined. And then lastly over here, the fourth type of line we can have is a decreasing line, and that's what happens when we get a negative slope. All right, next up, we're going to talk about a different form of an equation of a line that maybe you've never seen before. It's called point-slope form. So what we can do to get point-slope form is we can start with that slope equation, and we can just multiply by the denominator. So if we multiply both sides by x2 minus x1, then that cancels it on the left side, but moves it over to be multiplied on the right side. And so here is point-slope form. What we substitute into this equation are x1 and y1. That would be a point or a coordinate pair that is on your line. So any point that's on your line, you can actually plug those coordinates in. And then m, as we just talked about, is representing slope. So substitute your x and your y coordinate and your slope, and you've written your line in point-slope form. So let's do an example here. Given this point and the slope, let's plug them into our point slope form. So we're always going to say y minus whatever the y coordinate is. So plug it in exactly like it looks. We got y minus -2. We'll simplify that on the next step, but just plug it in as it is right now. Equals, we're going to plug in our slope, so 3. And then we got x minus our x coordinate. So our x coordinate being 1, we're going to have x minus 1. Now, sometimes we do have these double negatives, and in that case, you want to simplify that. Leaving it unsimplified is not entirely correct, so let's go ahead and simplify those double negatives. So our final point slope form is y plus 2 equals 3 times the quantity of x minus 1. And so when looking at this equation, you can see that one of the coordinates, or one of the points on the line, is 1 and comma -2. So it's slightly tricky in that if you're looking at the equation and trying to determine the points, you got to think backwards of where that positive came from. It came from a double negative. We'll practice that later in class as well. All right. Lastly, let's see if we can work between point slope form and slope-intercept form, something hopefully we're more familiar with. A lot of graphing utilities can't graph it if you give it to them in point slope form, so a lot of times we do have to convert into slope-intercept form so that we can graph it using a graphing utility or computer. All right, so we take that y plus 2 equals 3 times the quantity of x minus 1. We're going to simplify this right side. Essentially, we're solving for y. We're going to try and get y by itself. So let's distribute on the right. We're doing 3 times x and 3 times -1. So we get 3x minus 3. And then our last step to get y by itself, subtract 2. And so our final slope-intercept form is y equals 3x minus 5. These two equations give you the exact same line, just two different ways to represent it. This will tell you the y-intercept and the slope. This will tell you a point and a slope. All right, so you got a second example there. Go ahead and try that on your own. Pause the video while you do it, and then go ahead and check your work. All right, next up we have kind of an application using linear equations, although in class we didn't quite get to this. So I'm going to go ahead and leave it right here so that you can pause and take some notes if you want to do it. And then one more time, a second example there. But know that we didn't get to that in class, and we may or may not pick it back up. So no worries if you don't want to deal with it, but in case you're interested, there's a good couple application problems using what we just practiced. All right, next up, let's practice using that slope-intercept form. Make sure we're comfy with that. Given an equation in any form, for example, if it's given to us in general form, can we put it into slope-intercept form? And also, can we recognize any of those specific horizontal or vertical equations that are so special? All right, so given to an equation in general form, let's solve for y. Let's put it in that slope-intercept form. So just one step in this example, just subtract x or move it over to the other side and make it negative. So now we know that our slope, which is in front of the x coordinate, or the x variable there, is -1. And the y-intercept is always that last number, that b value on the end there. I like to state it in coordinate pair form, although if you said the y-intercept is 2, we would all know what you're talking about. I like to put it in coordinate pair form just so it reminds me that the x value is always 0 for a y-intercept. So that way if I want to check it, I can plug a 0 back in and see that my y-intercept is y equals 2. All right, if you get a y equals just a number, that is a constant function, meaning that the value never changes. It's always 3, so it's always going to be this horizontal line at y equals 3 all the way across the coordinate plane. A horizontal line has a 0 slope. It didn't go up or down. It just stayed flat. And whatever that y value is going to be the y-intercept. And then you can also verify that if you plug a 0 in for that slope spot, it's going to cancel that x variable, and you're just left with that original equation. Horizontal lines have 0 slopes and y equals equation. There's a special case, so we got to kind of memorize that. All right, one more example. Try it out. Go ahead, pause the video and check your work. We end up subtracting x from both sides, and dividing by -2. So dividing -1 by -2 gives us +1/2, and 4 divided by -2 is -2. So that slope is 1/2 going up over 2, to the right 2, sorry, up 1, right 2. And the y-intercept, 0, -2, or just -2. So positive slope is going to give us an increasing line. All right, one more set of examples here. And let's talk about parallel and perpendicular lines. Parallel lines are going to have equal slopes. That's what makes them stay the same distance away from each other and never intersect. If they had different slopes, they would certainly intersect at some point. So giving them the same slope guarantees that they stay parallel. Let's do a couple examples where we write equations of parallel lines. So given this initial line, so we're given this line that's graphed a certain way, although it's not given to us in any useful form, we want to come up with a second equation, an equation of a second line that is first of all parallel to this one given to us, and second of all intersects a given point. So this point is on the second line that we're coming up with. All right, so first of all, given this initial line, we want to know what the slope is because we know we're going to use an equal slope for our parallel line that we come up with. So first of all, let's solve this for y. Let's get it in slope-intercept form. We'll subtract 2x from both sides, and then we'll divide by -3. So that gives us y equals 2/3 x minus 5/3. So we know our slope for that line is 2/3. So a parallel slope has to be equal, so we know we're going to use a slope of 2/3. So now we have the information we need to write the equation of our second line because we have a slope and we have a point that is on the line. So if we have a point and a slope, we can start by writing point-slope form. So we're going to write y minus the y-coordinate of our point, y minus -1, equals our slope of 2/3 times the quantity x minus the x-coordinate, so x minus 2. Simplify those double negatives first. Distribute on the right here. So 2/3 times x and 2/3 times -2 will give us -4/3. Last step, subtract 1 from both sides. So essentially subtracting 3/3 will give us -7/3. So here is the equation of our second line. Go ahead and graph it and verify two things. Make sure that it's parallel to this equation, or this one, although you have to use this one to graph it. So parallel to this one. And this line has to be going through this point, 2, -1. You can check that on the graph, or you can actually look at your data table on your calculator and look at the input of 2. Does it give you an output of -1? If that happens, then you know that this line is running through that point and parallel to this. So you got a second example there for you to try out. Go ahead and pause it right here, try it out on your own. Check your work. All right, let's go on to our last set of examples here. Now we're going to try and do the exact same thing, except we're going to write an equation of a perpendicular line. So the only difference there is that our slope is going to change. So rather than using an equal slope, we're going to use a perpendicular slope. And perpendicular slopes are opposite reciprocals of each other. So not only are they opposite, meaning if one is positive, then the perpendicular slope is negative, or vice versa. They're also reciprocals. So remember that a reciprocal is the fraction flipped. So for example, taking this initial line, let's find its slope, solving for y, put it in slope-intercept form. We're going to subtract 2x from both sides and divide by -3, 2 steps. So now we know that the slope of that given line is 2/3. Its perpendicular slope would be the opposite. So rather than positive, it's negative. And rather than 2/3, we're going to flip it and make it 3/2. So opposite reciprocals. So again, we have a slope that we want to use. We have a point. We're going to use point-slope form to start it off with and simplify, solve for y, and write it in slope-intercept form. You got one more example there to use for extra practice. Go ahead, pause the video, try it out on your own, and then check your work. All right, so that concludes the video for lines in the coordinate plane. I'll see you in class.